Yeah, hi everyone, welcome to PrepFusion. So major update, GATE 2027 website has been launched and they have updated the syllabus as well. Okay, syllabus has been added. Now since the time this website has been launched, you guys are in the panic situation. You guys are panicking. I have received hundred of messages that sir, new syllabus has been added, some extra topic has been added, how to cover those topics. So everything we are going to discuss, what all new topics have been added, how we need to proceed in that. So that we are going to discuss, but only for EC. This video is for EC students only. For electrical and instrumentation, Anish sir will make a video. I have seen that some new topics have been added in electrical machines. Some topics of power electronics are also added in instrumentation. Okay, so that video Anish sir will make for electrical and instrumentation. We will talk about EC student. For electrical as well, I will also analyze. Anish sir will also analyze, but video will be made by Anish sir. Okay, here for EC student, I am making the video. Two things are there. First of all, there might be a little sound of fan in the background because currently the fan is on. Secondly, this frame is new. The last frame is broken. So you guys will take some time to get habitual with this frame. Okay, so let's get started. First, let's talk about the first section, which is engineering mathematics. In the differential equation section, there is no change actually. Okay, it's just the wording is changed. They are talking about first order equations. Like basically in a differential equation, what do we study? Basics of differential equation. Then we study the first order differential equation. Then we study higher order differential equation. And then we will study partial differential equation. Everything is same. Nothing is different here. Differential equation is as it is. Do not worry about anything about a differential equation. In the probability and stats, correlation and regression analysis has been added, which was already there in GATE electrical syllabus. It was there in GATE civil syllabus as well, and it was always on cards. If you watch this video, in this video as well, you would find me saying that the questions can be asked in EC as well. From regression analysis, you can see correlation and regression analysis. This thumbnail is also there. So this was uploaded 2 weeks back. Okay. So there also I said that this topic could be introduced in EC as well because it is the time of AI, right? And without studying regression analysis, you can never proceed with machine learning. So it is the time of AI. In the time of AI, I was already expecting that this syllabus, this particular topic will be introduced in EC very soon, and now it has been introduced. Okay. So correlation and regression analysis that you need to study without any formula, the pure concept we have studied in this particular topic. So you can watch this video and you will be able to cover correlation and regression analysis. And this year in GATE EC, I am expecting one question from it. Okay. Again, it is the time of AI. AI is the future. AI is the present as well, actually. Okay. So future, present, everything it is. So again, I can expect one question from correlation and regression analysis in GATE EC this year. So you can cover it from here. So this we have already covered. Nothing new here. Okay. Next section, electronic devices. So first topic in the basic semiconductor physics, they have added formation of energy bands in solids. Previously, what was the scenario? They would have started EDC from intrinsic and extrinsic semiconductor. Okay, this is how they would start. But now one more topic they have added, formation of energy bands in solids. We have already studied it. This is the video introduction to semiconductors, physics and fundamentals. So before moving into a semiconductor, first we talk about a solid, which is made from atoms. In atoms, there are electron, neutron, proton, right? And how the energy bands are framed in the solids. First we study that, and then we talk about the energy bands of semiconductors. So look here, completely we have studied about the formation of energy bands in solids. So this topic has been already covered. So do not worry about this particular topic. This has been already covered. When we start the semiconductor physics, this is what we start from. Okay, we cannot directly start from intrinsic and extrinsic semiconductor. Although we can start that this is a semiconductor, but you would never understand what was the difference between a conductor, semiconductor, and insulator. Why we moved towards semiconductor? What was the requirement of moving towards semiconductor? So this is how we start from. Already it has been covered in our syllabus. Nothing new here. Nothing new here. Next one is scaling in MOSFETs. Scaling in MOSFETs. Look, over the time in IC design, what's the concern? The concern is that the channel length should be as low as possible. So over the years, what we are trying to do, engineers are trying to reduce the channel length. This is known as scaling in MOSFETs. And it is the most important topic when it comes to interviews. Okay, as a IC design engineer, as a analog IC design engineer or digital IC design engineer, your first target would be that I will use the channel length as small as possible. When you use the small channel length, then there will be some non-idealities will also be introduced, which is known as short channel effect. So everything we have said about the long channel MOSFET as well and short channel MOSFET as well. Okay. This particular topic has been mentioned by Naresh Imani sir in their playlist. Naresh Imani sir, IIT Hyderabad, EDC playlist. they have mentioned this particular topic. This is there in our Niemann's book as well. And when I was teaching MOSFETs, I have completely taught everything about this particular topic, short channel effects and everything. So nothing new, we have already studied it. Although previously it was not mentioned in the syllabus, specifically it was not mentioned, but MOSFETs were mentioned, no? So what I thought was, if someone is studying MOSFETs, then most important topic is the short channel effect. You would see that I have made two to three times LinkedIn post that some question from short channel effect can be framed. Last year we took a booster X. In booster X as well, I framed one question from short channel effect. That means I framed a question from scaling in MOSFETs only in booster X. So previously it was not specifically mentioned. The world is moving fastly towards IC design. That's why they are introducing these topics. Are you able to understand this point? So this was also always on cards that this particular topic will also be mentioned in the syllabus. Sometimes like previously when I was teaching this particular course, there also I was thinking that this particular topic will be introduced in the syllabus, and it is introduced now. Although silently it was already there. Silently it was already there. They are putting up the MOS physics. No, you are supposed to study MOSCAP and MOS physics. So it was already on cards that they could ask questions from short channel effect as well. And this time they have specifically mentioned it. Instead of writing short channel effect, what they have written? Scaling in MOSFETs. So what you will do? You will scale that channel length, channel width, right? And then you will move towards the short channel MOSFETs. And what all effects could be there? What all known identities are there, right? So all these things are there. Device induced barrier lowering. All these topics are there, which we have already covered in the EDC playlist in this particular video. Body effect, energy band diagrams, and short channel effect in MOSFET. So this we have already covered. Do not worry about this particular thing. So about EDC, do not worry about a single thing. You are already good with that. Okay, nothing new here. Coming towards analog circuits. So in op-amp portion, what they have added? Miller compensation and phase margin. It is a clear indication that you do not study op-amp as a black box only. This is what they are saying. When we start op-amp, how do we start? Generally, that this is your op-amp circuitry, and this is how, then we will analyze it, then we will create some inverting amplifier, non-inverting amplifier, and we keep on analyzing our op-amps. They are saying that don't study op-amp like that. You study whatever that is available inside, that how this particular op-amp IC was made. This is what they are asking you to study. Okay, so this is the internal structure of op-amp. No? Have we already studied it? Yes. Have the question also been asked? They gave this particular circuitry in the examination, then they connected the feedback like this, and they asked you what was the gain. Although everyone says 1 upon A upon 1 plus A beta, but what was the intuition behind it? So that could be understood from this particular circuit analysis. So it has been also already asked in the gate examination in gate 224. Okay, so they are saying that you study the internal structure of op-amp. Now sir, here the topic is mentioned Miller's cap, but sir, Miller's compensation, but I don't see any Miller's cap. I don't see any Miller's cap like this here. So actually it would be present. When we studied this topic, we did not talk about Miller compensation in this particular circuitry. But have we already talked about Miller compensation? What is the meaning of Miller compensation? Let's just say I am having a common source amplifier, right? I am just making the small signal. Okay, small signal model I am making. This is the common source amplifier I am having. What is the gain? Gain is minus GMRD, right? So this is the flat gain. This will be your body plot. If I introduce a Miller's cap, then what will happen? This is the study of Miller compensation. That's it. If I introduce the Miller's cap here, then at low frequency it will provide high impedance. So you can simply refer it to the input side and the output side. You can apply the Miller's theorem. At high frequency, what will happen? This will drive some current. That means it will introduce a 0. So effect of 0 will be introduced at high frequency. At low frequency, what you will see? That it will introduce a pole. Right? And based on that, you can make the body plot. Have we studied all this analysis? Absolutely yes. Completely, we have studied all these analyses in our videos. When we talked about Miller's theorem, I told you that Miller's theorem has some constant as well, that when you can apply the Miller's theorem. And this is the meaning of dominant pole Miller compensation. We have completely studied it. Okay. And what about the phase margin and gain margin? So previously, I had already made a video. This video was there, stability analysis of feedback circuits. There I have already talked about phase margin and gain margin, that using the phase margin and gain margin, how you can comment on the stability of a feedback circuit. And this is what they are expecting. Here we have talked about Miller compensation as well. In this video only, in this 50 minutes of video, we have talked about Miller compensation as well. But previously what I used to say, that this video is very important, very important for placements. But if you are someone who is preparing for gate, then you can ignore it if you are not having much time left. This is what I used to say previously. If you are someone who is preparing for gate examination, then you can ignore it if you are having very lesser time. If you are someone who is having more than enough time, then you should study. But this is very important for the placement, because when you get into the industry, you would see that all you need to talk about, that is only one thing. What is that thing? That is the feedback. And feedback analysis we need to do with the help of gain margin and phase margin. Right? So from the placement perspective, I used to say that this video is very important, but now from the gate perspective as well, this video has become important. So this is some 50 minutes video. So here you can watch and you will get to know the stability analysis of feedback circuits. So if the question is coming from phase margin in the analog circuits, if the question is coming from phase margin, then whatever that we have discussed here, that is more than enough. This video has been made with the reference of Rajavi sir's video only. So whatever they would ask, I am pretty sure that they would ask from that much content only. Is that understandable to you? Okay. And what about Miller compensation and all? So we have studied Miller compensation in our MOSFET videos. Our MOSFET is of roughly around 42 hours, no? So there we have talked about frequency response, feedback topology. So again and again Miller's cap was coming into action. So more than enough analysis we have done. Intuitions also we have seen how it will introduce a zero, how I can determine the value of zero intuitively. Everything we have seen about Miller's cap. So more than enough we have studied. You do not need to worry about anything else. In the analog as well, there is nothing new from our side. Do you understand this point or not? Is that clear? Now someone would say that, sir, this particular topic, Miller compensation and phase margin, has been added in the op-amp portion, right? They are not treating as a separate amplifier. They are not treating as a MOSFET topic. They are adding it in the op-amp portion, no? That means they can ask the phase margin analysis or about the Miller compensation in the op-amp circuitry. The point is that yes, it is mentioned in op-amp, but at BTech level, I don't think they would be expecting so much of in-depth analysis. Like I don't think they can ask you the value of a feedback cap, what could be the value of feedback cap so that you get a particular phase margin of 76 degree. Okay, the best case phase margin, how will you get it? When you get into masters, no, then in analog, the initial project that you design, that would be two-stage op-amp. So there you will be talking about Miller's compensation, and you will be drawing the phase plot, you will be drawing the body plot, and then you will be able to comment on the phase margin and all. And your target would be to get the best possible phase margin, roughly around 75-76 degree. So I don't think at BTech level they will be expecting that much. At BTech level, what kind of questions they can frame in gate examination, that much knowledge we already have. If you want to study op-amp too much in depth, that everything about the stability of the op-amp, if you want to study, then Shanti Pawan sir's playlist is there. Specifically, you would see a lot of videos on this. But again, I am saying at BTech level, when you are preparing for gate examination, this is too much for you. Okay. So in the op-amp circuitry, internal structure of the op-amp, and there we are talking about the Miller compensation and phase margin and all. This much I don't think they are expecting. Shanti Pawan sir, I should need to write down. Okay. So Shanti Pawan sir, Professor Shanti Pawan sir, they have made a lot of videos on the stability analysis of op-amp. Okay, they have talked about Miller compensation as well and phase margin as well. They have given a proper design. And if you need to design in a cadence, then there is videos by Hafiz KT sir. So they have given a proper design, like they have designed on their own, they have simulated it as well. So proper design also you can see. But at BTech level, when you are preparing for gate examination with 10 subjects, you are not only preparing for analog, no? Only one subject you are not preparing. 10 subjects you are preparing, no? So I don't think that much depth they will be expecting. So whatever the depth they would be expecting, no, that we have covered. I can take guarantee on this. You just need to watch this extra video. Okay, if you haven't watched it, if you have already watched it, then it is good. Okay, uploaded on YouTube only, no need to worry about anything else. But this Miller compensation and everything I cannot upload on YouTube, no, because it is not treated as a separate topic. When we study about MOSFET amplifiers, when we study about the frequency response, there in between we study this particular topic. Okay. So yeah, that's the analysis about analog. Nothing new we need to study here in the analog circuits, nothing new. Understandable? So what we have talked about, mathematics, then EDC, and then analog. Next, we need to talk about control systems. So when we study control system, when we talk about compensator and controller, there we specifically study about PID controller as well. And Anish sir has already taught about PID controllers. Okay. This year I am taking control systems, so I will teach everything, whatever that has been mentioned in the syllabus. So do not worry about control systems. This year I am taking control systems. So whatever that has been mentioned in the syllabus, I will surely teach it. Okay. And sir, what about the YouTube audience? Sir, I'm a self-preparing student. What about the YouTube audience? So this topic, okay, controller and compensator, I will completely upload on YouTube. That's the promise I am making. That compensator and controller, this particular topic, I will completely upload on YouTube. Okay, that's a complete promise from my end. So no need to worry about control systems. Whatever that has been updated, that we will cover this year. Along with that, it has been already covered as well. Okay, PID controllers and everything, Anish sir has already taught, because this is very important for the instrumentation background student. Since they have added in EC as well, so we have already taught it. Along with that, you will this year I will be teaching, so I will also take this particular topic. So worry nothing about control systems. Understandable? Let's go to the next one. Communication. So someone is saying, people are saying that a new topic is added, source coding. When you study about coding in communication system, no, you cannot start this particular topic without source coding. Actually, a lot of people actually start directly from fundamental of error correction. But what I always believe is that first we will always start from source coding, because we need to understand the meaning of source coding. No, so last year this particular topic was not there in the syllabus, but I have already taught it. To understand the actual meaning, of coding in communication system. So this is where we start from actually. This is the first topic that I used to teach, that is source coding. So do not worry about this. Already we have studied this particular topic. Okay, source coding in this information theory playlist. So you can go and simply you will get a chapter as well. Like this is a 6 hour 14 minutes video, no? So here there are different chapters: source coding, fundamental of error correction, Hamming codes, CRC. Okay, cyclic codes. In this mainly we study about CRC only. So 4 chapters you would see. The first chapter you can study. If you want to study the complete coding part, then I would say I would highly recommend watching this particular video, because again this is one of the most important part for the modern day communication techniques. Okay, information theory has become very important topic now. Why is that so? Because the way we are moving in future, information theory is a very important topic. Information theory and coding. So information theory is a separate part, coding is a separate part. So that becomes a very important topic. So we have already covered source coding as well. So here as well, nothing new. Sir, you are saying there is nothing new. So it is what it is, because we have already studied everything. Okay, when we study the subject, we don't study just as per the GATE syllabus. We always keep on thinking that what could be asked in the GATE examination without even mentioning in the syllabus, because they will silently mention the topics. No, so all these things like feedback topology and everything has been mentioned. No, so I thought that feedback circuit also they can ask. That's why I taught it. So everything I already taught. It's not that you might be thinking, sir, I am doing the marketing or anything. So I am putting up the screenshot as well, that where I have taught it. Okay, all these things are uploaded on YouTube as well. So that's why there is nothing new. You are just feeling that, sir, a lot of new things are there. But when we actually start those topics, no, then this is how we start. When we study about MOSFET scaling, we will surely study, because there is no meaning of studying MOSFETs in the crude way, right? Because the way we are moving towards new technologies, so surely you need to study about the short channel MOSFETs. Like when you get into the industry, what do you think? Will you be working on MOSFETs? There are very rare chances that you will be working on MOSFETs. You might be working on FinFETs, or you might be working on some other technology, right? So, but the effects would remain same. The channel length might be different, right? But the effect would remain same. If you know the physics of MOS, then you would know that, then you would be able to understand the physics of some other device as well. Are you able to understand this point? So when we study in depth only. So everything has been covered. Scaling in MOSFET, this particular topic I have already seen in Naresh Imani sir IIT Hyderabad playlist. From there I picked up this topic and made this particular video. So in this video we are only covering what has been covered in this particular topic. And it was there in Niemann's book as well. I can show you that. So everything we have already covered, right? Regression analysis, correlation analysis. In this video as well, you will find me saying that this could be added in EC as well, because we are moving towards AI, right? So now today, this year, this has been added. Last year in booster X only, you would see there is a question from short channel effect. From scaling in MOSFETs only, there is a question from my side in booster X. Okay. And this always I used to say that never ever study op-amp as a black box directly. If you want to study op-amp, then first design this, then treat it as a black box. So we have already studied the design of it. This is op-amp only, and then we treat it as a black box. And this is directly I'm not picking the circuit. I'm starting from here, that one by one, everything we have studied. This is known as two-stage op-amp. Although Miller compensation and all at a BTech level, I did not think that in the op-amp circuit it would be introduced. But Miller compensation and everything you already know, right? Then I thought that phase margin, gain margin, stability, this is something that we need to talk about, that we have already talked about it. Are you able to understand this point? Okay. In the digital section and electromagnetic section, everything is completely identical. There is no changes. There are no changes. Okay. Digital circuits and EMFT completely identical with no changes at all. Now coming towards signals and systems. In network analysis, there is no change. Network analysis, no change. Let's come towards signals and systems. Okay. Sampling theorem and application has been replaced with the Nyquist sampling theorem, sampling and reconstruction. This is just that change of wording, nothing else. They are only talking about sampling in detail in roughly around 6 to 7 hours with all the questions and everything. We have covered sampling. Not a single question will be asked apart from that. I can guarantee this particular thing. Okay. So sampling in detail we have covered. On YouTube only we have covered. Sampling video is uploaded on YouTube only. LTI system sampling in that manner, that is the title of the video. So there you can see. So this is just the change of wording, nothing new here. Now in the discrete time signal, there is something new, which is FIR and IIR filter design. Okay, that's a new topic that they have added. Filter design. If you watch my last year's video, I was always saying that within some time, within some years, you would see that signal system will completely move from continuous signal to discrete signals. Why is that so? Because when you get into the industry, you do not analyze continuous signals. You cannot take infinite samples. You need to take a certain set of samples. So when I'm analyzing in the time domain, then also I will take a certain set of samples only at some particular time. So if you are taking a sample at a particular time, that means you are dealing in the discrete time signal. Same goes with the frequency as well. You cannot analyze all the set of frequency from 0 to infinity. You analyze some particular set of frequencies that at this particular frequency, what is my response? And based on that, I will do my analysis. That means you also deal in discrete frequencies. So there, your discrete topic becomes important. The point is that when we see the PYQs, 80% of the PYQs are from continuous part, right? And 20% of the PYQs are from discrete part. When it comes to electrical, 95% of the PYQs are from continuous part, 5% of the PYQs are from discrete part. This is what we have observed, right? But slowly the scenario is going to change. In electrical, this year only it changed. I guess 40% of the PYQs came from the 40% of the questions came from the continuous part and 60% came from the discrete part. In electrical, GATE 2026. In electrical, I guess this was the scenario as far as I remember. And this I said even before the examination. Then in future you would see by 2027, 2028, 2029, 2030, I'm telling you, you would see that more questions are coming from the discrete part and lesser questions are coming from the continuous part. Are you able to understand this point? Although to understand the discrete analysis, you need to have a good knowledge of continuous analysis, then only you will be able to understand the discrete analysis. But from the industry point of view, this is more important. Okay. So FIR and IIR filter design they have added. Have we already studied it? Yes, we have studied about FIR and IIR filter. This is the discrete portion that we have studied. Everything is uploaded on YouTube. You would see in these videos, I am talking about FIR and IIR filter, finite impulse response filter and infinite impulse response filter. And believe me, last year in one of the All India mock test as well, I have framed one question from FIR filter. One question from FIR filter I also framed. Because I always know that we are moving towards discrete domain analysis only. So it might be possible that some question can be introduced. So one question I framed from FIR filter. The point is how we have studied that filter is given. Okay, filter is given and we study the analysis of that particular filter. But if you see that topic, what they have put the word design. That means they give you a specific requirement. Based on that, you need to know how I would design my FIR and IIR filter. So they have put the word design. Is that understandable to you? So I am pretty sure you would have studied filter design or FIR or IIR filter design in your BTech. In 7th semester or 6th semester, there was a subject called DSP, discrete signal processing, right? So there we used to study the filter design, direct method 1, direct method 2, Butterworth filter, right? All these things you have studied, no? Bilinear transformation from continuous time to discrete time transformation, you need to find out. All these things you have studied. The point is this topic is very large. This topic is very large if you study in depth. Like this topic itself would be of roughly around 25 hours if we are going to study in depth FIR and IIR filter design. If we need to study the design part. But we cannot do this, right? We cannot spend 25 hours on the design only, on the FIR and IIR filter design. How would you prepare other subjects? So basics of FIR and IIR filter we have already studied in these videos. In the discrete part only you will get, mostly I guess it is there in either in digital filters or in this particular video. Somewhere we have discussed about FIR and IIR filter, because I clearly remember it. Okay, I clearly remember it, that somewhere we have discussed. But the point is that since they have mentioned design, so we will study about some design method as well. Some design method also we are going to study. So this video I will make, surely I will make, don't worry about it. But it is not that important that your whole question paper or your whole signal system will not be framed from one topic. Hardly one question would be asked, and if it is asked, you will be able to solve that particular question. That guarantee I am taking. So yes, this video I need to make. FIR and IIR filter design video I will make. Rest everything in the new syllabus, with the change of the syllabus, everything completely right from scratch, everything has been taught. Nothing extra is there. With the proof, with everything, with the complete explanation I have put. Also, I have given the explanation that why they are introducing these topics. Also, I have given the proof as well that in BoostRx you would see a question from my side. In FIR filter as well you would see a question from my side. In one of the AIMT, I don't remember which AIMT it was. It was three All India mock tests we conducted. So which All India mock test it was, that I don't remember actually. So this is the complete analysis. I hope you would have understood. If you are someone who is preparing for some other platform or from YouTube, then coming to this topic, regression and correlation analysis, you can cover from here. Then electronic devices, scaling in MOSFETs, if you need to cover, then you can cover from this video. It is the last video of MOSFET, body effect, energy band, and everything is uploaded on YouTube. Okay, don't worry. So body effect, energy band diagram, source channel effect. So it is uploaded on YouTube. It is the second last video or last video of MOSFETs. So there you can cover it from. Formation of energy bands, no matter from wherever you are studying, they will always start from here, because this is where you would start EDC from. If you are not starting from here, then there is a problem. So you can study, this is the first video of our EDC, Introduction to the Semiconductor. You can study from here. Analog circuits. So the point is that dominant pole mirror compensation, there is no separate video for this. This designing two-stage op-amp, this is uploaded on YouTube only. You can study from here. Okay. If you need to study about gain margin, phase margin, stability analysis, this video is also uploaded on YouTube. You can study from here. Control system I will bring. I have already promised compensator and controller. Communication source coding, again uploaded on YouTube only. If you are someone who started studying from the fundamental of error correction, then you should start from source coding. You can study from this particular video. Digital and electromagnetics, no change. Sampling, they have put some different words. So this year I am expecting, and not this year, every year I expect that one question would be there from sampling, because it is very important topic. So from sampling, every year question also come. So yes, sampling question would come, but this we have already covered. This is just the change of wording, nothing else. Discrete time signal, yes. Design word they have mentioned. If they would have just mentioned FIR and IIR filter, no, then it would have been fine. But they have mentioned the word design. So there are some separate design methods which we will cover in brief within 1 or 1.5 hours, so that if a question is coming in the gate examination, that question we will be able to solve. If you want to study discrete analysis in detail, then this is how you can study. Mostly discrete analysis is covered in 4 to 5 hours only, or 6 hours they cover. But this is how we have covered the discrete analysis. You watch this video, you will realize the beauty of electronics. Okay, you will realize the beauty of signal system. So this is the videos. These are the videos. Okay, yeah. Thank you very much. Happy learning. So electrical videos will also come, and along with that, we are currently running a discount code. The code is PREP. You can apply the code till tonight. It might be extended for tomorrow as well, but as of now, the scenario is that it will be applicable till 11:59 p.m. tonight. Okay, thank you very much. Happy learning.